All right, well, good morning, everyone, and welcome back to another exciting day in mathematics. How's everybody doing? Good? How's home plate? Yeah, let's go. So your warm-up, number 42 is on the screen. For number 1, we got simplify. Part A reads square root of 12, and part B reads square root of 1/5. It's on the screen, it's missing the little bar for the fraction. Make sure you put that in there. So square root of 1/5. Number 2, it says add, subtract, multiply, and divide. They give us two binomials, I minus 9 and I minus 4. Part 3, or problem number 3, it says factor by grouping, and they give us a polynomial 3x squared plus 7x plus 2. And number 4 says graph g of x equals parentheses x minus 4 close parentheses squared plus 2. Let's see how you do with those. We already did some on our previous session, and hopefully you should be able to do all of them by yourself. Copy that and go. All right. So let's see what we got. I'm going to go ahead and go over these expeditiously. Bam, how about them big words, huh? Just for the sake of time, because I need to get us moving. So number 1A, simplify square root of 12 becomes square root of 3 times square root of 4. What is square root of 4? 2, and bring down square root of 3. So we have 2 square root of 3. 1B, we have square root of 1/5. So I need to rewrite this. This becomes square root of 1 on the numerator, square root of 5 on the denominator. But according to the definition, we cannot have a square root on the denominator. It has to be an integer. So to change this, I need to multiply it times whatever is on the denominator, which is square root of 5. And whatever I do to the denominator, I do to the numerator, times square root of 5. So that gives me, on the numerator, 1 times 5, that's square root of 5. On the denominator, 5 times 5, that's square root of 25. And if I simplify that, let's see. Numerator stays at square root of 5. I can't simplify anymore. Square root of 25 is 5. And now this is simplified because we no longer have a radical in the denominator. For addition, we combine like terms. I plus I is 2i. Negative 9, negative 4, that's negative 13. That's for addition. For subtraction, remember we need a negative to be distributed or changing these to their opposite. So I minus I cancel. And negative 9 plus 4, that's negative 5. Multiplication. When I multiply and distribute these, I get I times I is I squared. Negative 9, negative 4i, that's negative 13i. And negative 9 times negative 4, that's positive 36. And remember, this one can be simplified a little bit more, but today we're going to get to that hopefully towards the end. And division, once you divide this by this, you get 1. And then you have negative 5 over I minus 4. To factor, remember, don't forget to multiply this times this. So that is 6. 6, and then 7 down here. Factors of 6 that add up to 7, that's 6 and 1. And you write 3x squared plus 6x plus 1x plus 2. You group. GCF here is 3x, we're left with x plus 2. GCF here is 1, we're left with x plus 2. So my factors are x plus 2 and 3x plus 1. And last but not least, we look at the graph that they want me to graph. G of x equals parentheses x minus 4, close parentheses squared plus 2. First, I identify what kind of graph is a parent function. Well, this one has a squared here, so it's a quadratic function. So my initial, or my original one, should have been f of x equals x squared. And what does that look like? Well, if I graph it, we got negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. There it is. And I identify the parameters that they give me on the transformation. The parameters given are h, that tells me to go to the right 4, and k, which tells me to go up 2. So I take each one of these points and move them 4 to the right and 2 up. So I go 1, 2, 3, 4, 1, 2. This one, 1, 2, 3, 4, 1, 2. 1, 2, 3, 4, 1, 2. 2 and 2. And there it is. Once again, it moved everything 4 to the right and 2 up. All right, hands, have you got something like that? Yes? Okay. All right, let's move on. Our agenda for today, warm-up number 42. We are still in quadratic equations, and our home plate for today is only 2 pages, 122 and 123 only. And once again, as we are moving forward and our concepts are getting a little bit more rigorous, you make sure those of you that need the extra support attend tutoring right after lunch, especially today since we're moving on to funner stuff. Yeah, let's go. All right, your asynchronous session code is NZL3M, NZL3M, NZL3M. And your previous home play is on the screen. You had 4 problems to do, and you needed to solve them using either graphing, square roots, factoring, quadratic formula, or completing the square. Turn that in on Canvas, please. Now, on Canvas, if you are on your home page, which looks something like this, make sure you go to, go to modules. And since that practice that we just did is no longer in functions, now it's in what? Quadratic equations. You go to your quadratic equations module, down arrow, and it should be right here, 4 problems completing the square and quadratic formula. Make sure you turn that in there, please. Also, reminder, those of you that have not turned in your permission slip, make sure you go and turn it in ASAP. Once again, reminder, home plate is pages 122 to 123, all only. All right, here we go. Our objective for today, I can solve and graph quadratic equations by completing the square and quadratic formula. Once again, I can solve and graph quadratic equations by completing the square and quadratic formula. And just to revisit, what concept are we still on? Quadratic equations. So fill in your fairy model by yourself. I'll give you 1 minute for that. Give me a definition in your own words, 1 example, non-example, and a hashtag without looking at your notes. All right, do that right. All right, so you should have finished your fair model by yourself. Make sure you keep that in your notes. So let's recap of where we've been. So we started off with example Q, and I went over how to solve a quadratic equation 3 different ways, which we did on the first semester by graphing, square roots, and factoring. I had given you the function or the equation x squared minus 4 equals y, and we solved it all those 3 different ways. But then I said, today we're going to move on to the next one. We moved on to completing the square. So we did example 1, and it says solve by completing the square. And we went to example 1Q, one similar, we did together. Then we went to example 1 mega Q, which now had a leading coefficient of -3. And then from there, I gave you guys a one that had a different look, which was example 1 Michael Jordan Q, which was x squared plus 10x equals -9. And I said, this one, if you notice, the constant is on the other side of the equation, which means that they already did steps 1, 2, and 3 for us, and we needed to continue by completing the square, okay? So from there, we went to our favorite one, which was quadratic formula. You guys remember that, the quadratic formula? X equals minus b plus minus square root b squared minus 4ac over 2a. So from there, I gave you guys a problem where we can use a quadratic formula. For example, number 2, it said solve using quadratic formula, and I gave you guys x squared plus 16x equals negative 15. And I gave you 3 different steps. First step was to set it in standard form, which means bring the negative 15 to the left side. From there, identify A, B, and C. Once it was in standard form, it was easy to identify those. And number 3, we need to substitute that into a quadratic formula, simplify and solve. Okay, so we're good with that, right? So up to right there, how many different methods of solving quadratic equations do we know now? Show me with your hands. How many different methods? Yes, good. 5 different methods. Pretty good. Just, yeah. Here goes the methods. We started with graphing, square roots, factoring, completing the square, and quadratic formula. 5 different methods, people. And from this point forward, guys, basically now that you have all the different ways of approaching quadratic equations, you get to choose which method you like the most. And I'm pretty sure some of you are like, oh, I love completing the square, Mr. Q. All right, well, whatever method you're gonna want to use it. You have 5 different ways of solving them. But the purpose of today, guys, is, for those of you that have been with me before, is that second semester, I usually start focusing now on applications and word problems. You're like, my favorite, Mr. Q. I know, right? So semester 1 is usually to get used to and know all the different dynamics and all the different steps and the processes. And second semester, we add a little bit more rigor, and then we add our applications now. Okay, guys, ready? So now that we're going to start dealing with word problems and applications to real world problems, there's some problems that are most commonly used. So write this down. Common used equations in quadratics. Here we go. Common used equations in quadratics. Common used equations in quadratics. So whenever they're talking about problems in quadratics, but applying them to the real world, there's these common ones. The first one has to do with distance fallen in feet at time t in seconds. The first equation that is mostly used is this one that has to do with distance fallen in feet at time t seconds. And that function looks like this. D of t equals 16t squared. That's the first most common used equations in quadratics to solving real world problems. The second one, the most common one, has to do with height in feet at time t. Height in feet at time t, but then it says where h sub 0, look at, there's a little 0 right there, h sub 0 is the height, or the initial height, my bad, is the initial height. So wait a minute, how many heights do we have, Mr. Q? There's 2 of them, the height in feet and the initial height. So a height in feet is usually something that they want us to compute, and then they give us an initial height, but we still have to do with seconds. And here's that equation. That equation reads h of t equals h sub 0 with a little 0 down underneath the h minus 16t squared. Those are the 2 most common equations used to solve real world applications for quadratics. Now, if you are like me, since I was a kid, I remember I used to, with my cousin, we used to tear apart some radios to see how the speaker worked and how you connect the speaker. And then inside it has a little power generated with a magnet. I remember we used to pull it out and there's this little filament inside. And anyways, we used to find out what each piece did. Same thing here, guys. If you notice here, each piece has a purpose. So here, the letter T here, the T squared, is for T in seconds. However, distance fallen in feet goes on this side, which is D of T. D of T is the distance fallen in feet, D of T. And over here, T is what? In seconds. Look at this one right here. H sub 0 is the initial height, which is this. And then height in feet, or whatever the other height is, goes right here. And of course, T is still in seconds. So what's the only thing that is not accounted for from these two equations, guys? The 16. Does that make sense? Yeah? We know where the other ones are coming from, but except 16. Well, I'm not going to get too into it. I'm just going to give you a rough idea. Now, for those of you that have been with me in the past, do you guys remember that I used to have my basketball in my classroom right there next to me? You guys remember that? Yeah. So, and for those that don't know, I got skills. Oh yeah, Hayden, I got basketball skills. So if I was to take a basketball, this is my book, but if I place it on my finger, I would be able to spin it forever because I am able to balance it. But it's not really that. You know what keeps it so balanced on the finger when I start spinning it? It's something that we call in science gravity pull. Gravity pull. When the ball spins, all of a sudden it starts trying to collapse on itself. That's why that creates a force that is called gravity. Now, if we expand that idea to the world, what do we know about the world? It's a sphere and it's spinning. That creates a force of trying to collapse on itself, which means there's a pull towards the center of the earth. So whenever the scientists were able to compute or come up with numbers in regards to when somebody was trying to get away from the earth, that's another force. When somebody's trying to get away from the earth, and with the gravity pull, there's two different directions. They somehow came up with a number of 32 point something that was called a G-force. So whenever an object is trying to go away from the earth and there's the gravity pull because of the spinning of the earth, there's two forces there. It came up with the number 32 point something. However, today we're looking at objects only going in one direction, which is towards the floor. That means instead of using 32, what are we going to use? 16, because we're not using both directions and we're only going in one direction. And that's where we get the 16 from. Just FYI, BTW. I know you guys were like, oh, I can't live without, what does 16 mean, Mr. Q? Anyways. All right. So with that said, y'all ready for an application? Yes, Mr. Q. All right, good. Copy this, please. Example 3. Make sure you write everything down, please, because I want you to have this as an example because you're going to be doing this for home play. You need to have everything down. It says, example 3, write and solve an equation to answer the question. When you answer the question, guys, by the way, I want a sentence. Now that we're going to be applying it to a real world problem, I want to make sure that you understand what you're answering. And it says, give the exact answer and, if it's irrational, a decimal approximation to the nearest tenth of a second. Problem number 3 reads, if you drop a water balloon, how long does it take to fall 4 feet? Copy that. I'll give you some time. And then I'm going to help you with, we're going to sketch a diagram for those of us that are artistically challenged. I'll give you some time. Copy and go. All right. All right, so here we go. First, I'm going to have you sketch a diagram over here on the side. Follow after me, please, because I don't want you guys to get lost. And I know, like I said, some of you are a little bit challenged with your skills, but some of you that liked geometry last year, so you'll be pretty familiar with some of these sketches. So here we go. So line straight down. Ray going this way, and I'm sorry, a line segment going that way. So far, so good? Yeah? Victor, you good up to right there? Okay. Then we do this way. Straight line that way, like so. So far, so good. Over here on top, careful with this one. Bam, let's go. See how I reeled you guys in? Pretty good, right? So right here, let's draw our balloon. There you go. Now, once again, for those of you that are artistically challenged, if you want to add some color, there you go. In blue, go like this, like it's shiny. Put a little bit of effect here. And then in case people don't walk into your, if somebody walks in, make sure you draw an arrow from balloon to that so that they know what they're looking at. Pretty good, right? Bam. All right, so it says, if you drop a water balloon, there's a water balloon, how long does it take? So in red, I want you to underline the question, how long does it take? So there, they're asking how long in regards to time. So let's write T, and we're gonna put a question mark. That's what we need to answer at the end. We're solving for T. However, what else do they give me? Let's see, they give me that it falls 4 feet. So what does that mean? Isn't that a distance? Yeah, that's a distance. All right. So notice on this one only has one distance and time. Look at the formulas or the 2 equations that we wrote down. Which one only requires one distance and time? The first one, right? So therefore, we're going to write our first equation, d of t equals 16t squared. And so that we know what we're looking at, label the t in red, so like that we can match it to over here to what we need to solve at the end. So that only leaves us with what? With this. So what are we going to substitute in here? Well, guess what? We substitute 4 in there. So that leaves us with equals to 16t squared. And all that's left is to solve. And then we answer the question. Here we go. So to solve this, let me draw a line down the equal sign. I need to leave t squared by itself. So 16 is multiplying. So I need to divide by 16. Divide by 16. We're left with t squared equals to 4 over 16. How do I cancel this squared right here, guys? Oh, I see, Mia. Yeah, square root. Yeah, square root. This cancels this. I'm left with t equals. Now let's write the square root for numerator and denominator. So square root of 4 on the numerator, square root of 16 on the denominator. Okay. Can we simplify that? Yeah. What is square root of 4? 2. What is square root of 16? 4. That is equal to t. Can we simplify this fraction though? Yeah, it's 1/2 or 0.5 equals t. Now, before I move on though, look up please. Usually when we take the square root, look up guys, whenever we take the square root, we usually end up with a plus minus, is that correct? Okay, however, look at the problem now. The question was, if you drop a water balloon, how long does it take to fall 4 feet? And remember that t is in what? What kind of unit?
Seconds.
Seconds, so that's true. So this is in seconds. So according to what we came up with, how long does it take? It takes 1/2 second to fall to the floor. So if we go back to here, look up, can we use negative seconds? No, we're not in Back to the Future. So we can't use negative seconds. So that means from this point forward, guys, whenever we are dealing with applications, make a note for yourself from this point forward, whenever we're dealing with applications which involves distance and time, we don't have any negatives. We only use the positive square roots. So let's write our answer here in a sentence format. If you drop a water balloon, how long does it take to fall 4 feet? It takes the balloon half a second to fall 4 feet. 10Q. Let's see, for those that are, this is the first year with me, what do you think 10Q means? What do you think, Jaziel? What does 10Q mean?
I don't know. Thank you.
Thank you. Let's go. Anyways, I clarify that because I bumped into a teacher 3 years ago, I think it was. And before I used to do trainings for different districts. And I remember at the end of the training, I used to finish with a slide that said 10Q. And she's like, Mr. Q, I hadn't seen her like in 12 years or something like that. So I've been meaning to ask you a question after we chatted for a little bit. I'm like, yeah, you would finish your trainings with, on the screen, it said 10Q. But I didn't want to ask because I didn't want to seem like if I didn't know the math problem that you gave us. What does that mean? I'm like, 10Q? 10Q. She's like, oh my goodness. I waited 12 years for thank you. Anyways, that's neither here nor there. Anyways, show me with finger how come you're with these kind. So far, so good. 5, 5, 5, 5, 4. Okay, good. Let's move on. So once again, notice on this one, we had time and we had one number for distance. Let's go to another problem. Here we go. Example Super Q reads, the rooftop of a 5-story building is 50 feet above the ground. How long does it take the water balloon to drop from the top or from the rooftop to pass by the 3rd-story window at 24 feet? They give us a little diagram on the right-hand side of the building. On the left side, it shows that it's 50 feet. And then on the right side, it shows the height of 24 feet up to the 3rd story. Copy that, please, and I'll give you some time. Like I said, I know some of us are artistically challenged, so relax. We're in a safe environment right here. All right, do your best. Give you some time. Go. All right, so let's see what we got. It reads once again: the rooftop of a 5-story building is 50 feet above the ground. How long does it take the water balloon drop from the top or the rooftop to pass by the 3rd-story window at 24 feet? So first, let's underline the question. What is the question that we need to answer? It says, how long does it take? I did that in red, and I'm going to point it out obvious that I need to figure out the time it takes. Time, question mark. And we know that time is in what? Seconds. Okay. So that leaves us with 2 amounts, because the rooftop of a 5-story building is just a description, but we have 2 amounts. We have 50 feet and we have 24 feet. However, which would be the initial height that they gave us? What do you guys think? What's our initial height?
50 feet?
50 feet. So label 50 feet on your diagram. Since this is the initial one, we label it H with a little sub-0. So that means that 24 feet, this one over here on the left side, we're going to label it H of T, because that's the height that we need to figure it out. So now let's look at the entire thing. Look at it. I admire it from afar. What do you notice? We have 3 things. We have time, we have height, and we have another height. So look at the 2 different equations that we wrote down earlier. Which one would you use to figure out this problem? Which one has 2 different heights? Alyssa, can you read me which one would you use to solve this one?
I use the h of t equals h sub 0 minus 16 t to the second power.
Yes, that is correct. Thank you. Write that down. So h of t equals h sub 0 minus 16 t squared. Now let's label the things that we know that we have already. We know that t we need to solve. That's in red. We know h of t goes over here in green. And h sub 0, we substitute in here where we have the h sub 0. So let's start writing them underneath whatever we have. So here we have 50, goes right underneath h sub 0. And h of t is 24 on the left side of the equation. Then we bring down the equal sign, the negative 16, and the t squared. T squared. All right, so to solve this, line down the equal sign. I need to leave the t by itself, but right now it has a negative 16 next to it. So we need to get rid of this positive 50. So to cancel this positive 50, we what? Subtract 50. Subtract 50 from each side. We end up with negative 26 equals negative 16 t squared. We still need to leave t squared by itself. Negative 16 is multiplying, so the inverse is divide by negative 16, divide by negative 16. This is a giant one. We're left with t squared equals negative divided by negative is a positive, so we're left with 26 over 16. Still need to solve for t, so how do we cancel that squared? Well, the inverse is square root. Whatever we do to one side, we do to the other. This cancels this. We're left with t equals. I'm going to write these square root for the numerator, which is square root of 26, over square root of the denominator, which is square root of 16. Can we simplify this a little bit more? Yes. Square root of 26 over, what is square root of 16? 4 equals t. Now, mind you, look up the denominator, since it's already an integer, I can stop there. However, this still doesn't make sense. Look at it. Square root of 26 over 4. What does that mean? Like if somebody was asking you in seconds, what does that mean? Well, let me get my iPhone out or my Samsung and no. So how can we make sense out of this? Well, let me show you this. Look up. I want you to circle the square root of 26. What we're going to do next, we're going to do approximately so that we can wrap our brain around as to what is it that we're looking at. So question, we can't take the square root of 26, but what number is close to 26 that we can take the square root of?
25.
Yeah, so I'm going to rewrite this as, I'm going to go this way, square root of 25 over 4, and now instead of being equal, because equal means that that's exact, I'm going to write approximately, put the wiggles on like that, equals to t. Does that make sense? So we're approximating so we can make sense out of what we're looking at. So question, what is square root of 25? Oh, now I get it, Mr. Hugh. It's 5 over 4 approximately t. So how many times does 4 fit into 5? Or what do we get as 5 divided by 4? 5 divided by 4 is 1.25 approximately t. And now we can make sense out of that. Is that correct? Yes, Mr. Q. So what does this mean? 1.25. What does that mean, Mia? 1.25 what?
Seconds.
Seconds. So now we can actually answer our problem with a sentence. Once again, any word problem needs to be answered in a sentence format. If I don't have that, you get a 0. All right. So here we go. It says, how long does it take the water balloon drop from the top of the, from the rooftop to pass by the 3rd story window at 24 feet? Okay, so write your sentence. And if you can share that, let's see, what would be your sentence? Help me out. Let me see, pick, Danny, what would be a sentence to answer that question?
The water balloon takes 1.25 seconds to pass by the third story window.
Nice. The water balloon takes 1.25 seconds to pass by the third story window. 10Q. That is correct. And Danny, let's go. All right, show me your fingers. How come you are with these so far? Yeah, 5 fours, 5, 5, 5 fours. Okay. So really quick, let's look at the two different types of problems that we've seen using the applying those two equations. So once again, sorry. We have example 3, which was a problem involving a balloon, but notice they only gave us time and one distance. That's why we use this equation d of t equals 16t squared. From there, we moved on to a different problem, which was this one of the building, but now we had how many distances? 2, the height and the other height and time. That's why we use the equation h of t equals h sub 0 minus 16t squared, where h sub 0 was the initial height. That means the other height was the other distance. All right, let's see how you do by yourself on 1. Here it is, example 3 super Q, copy this. It says, on the moon, the distance d in feet that an object falls in t time in seconds is modeled by the function d of t equals 8/3 t squared. Suppose an astronaut on the moon drops a tool. How long does it take the tool to fall 4 feet? All right, copy that. I'll give you time to set it up, and I'll give you a little bit of time to see if you can do that one as much by yourself. And then I'll come right after so we can do finish it off together. Copy and go. All right, so let's see. First, once again, I'm gonna underline our question to see what they're asking. It says, how long does it take? Once again, they are asking us to compute or figure out the time. And what do we know time is in seconds? So we need to figure out the time in seconds. Okay. So what else do they give us? Let's see, they give us a tool to fall 4 feet. That is a distance. Okay. Do they give us any other height? No. Okay, what formula would we use? The original formula, the first formula. However, in this case, they actually give us the formula to use. So I'm going to write d of t equals to 8/3 t squared. Now we know that the t is for the time. So that means that for the distance here, we're going to substitute what? 4. So that goes 4 right there. And we have equals to 8/3 t squared. So to start solving this, we need to leave t by itself. I need to get rid of 8/3, that's multiplying. So that means we need to either multiply times 3 divided by 8 or multiply times the reciprocal, 3/8, both sides, 3/8. So this becomes a giant 1 right here. So we're left with t squared equals. So 4 times 3, that's 12/8. All right, and how do we cancel this squared? We take the square root. So we're left with t on the right side. On the left side, we have square root of 12 over square root of 8. Question, look at it. Can we take the square root of 8? No. However, now I hope some of you caught this. Who notices that this is kind of like what we did with a warm-up? Oh, Mr. Q, I see what you did. I know, right? So if we take this square root of 12 over square root of 8, can we leave it with a square root on the denominator? No, that means I need to multiply times square root of 8 in order to get rid of that square root right there. But whatever we do to the denominator, we do to the numerator. So this becomes 12 times 8, that's square root of 96, over 8 times 8 is square root of 64. So if I simplify this, square root of 96 over, what is square root of 64? 8. So notice now on the denominator, we already simplified. And we're done. That's our answer. But does this make sense? No. So what skill did I ask you to do after that to make it make sense? To try and do what? Approximate, right? Okay. So look at the square root of 96. What does that come close to? Michael, what number is close to 96 that we can take the square root of? What do you think?
96.
Yeah, square root of 96. What number can we take a square root of that's close to 96?
94.
Can we take the square root of 94?
100.
100. So we write square root of 100 over 8 approximately t. So what is square root of 100? 10 over 8 approximately t. So if we divide that, 8 fits in there, 1.25 approximately t, and that's in seconds. So if we answer the question, let's see. It says, how long does it take the tool to fall 4 feet on the moon? So what would be our sentence? Who's got my sentence?
It will take the tool 1.25 seconds to hit the ground.
Thank you. It will take the tool 1.25 seconds to hit the ground. Important, on the moon. 10Q. Ooh. And so on and so forth. And that's pretty much going to be the applications for quadratics, guys. Okay. I have one more thing to cover before we leave. Finish off your sentence. So we've been working so far with imaginary numbers, and I've been telling you that we're getting closer to using those in the next session, which is coming up pretty soon. So today, I'm going to do a quick recap as to where do we get imaginary numbers. So here we go. Imaginary numbers. Write that down. Where did we get this from, Mr. Q? Well, we said that imaginary numbers we needed to use because when we introduced real numbers, we knew that real numbers, there is no such thing as a negative square root. So since negative square root of 1 cannot be simplified, we said this is known as an imaginary number, or I. Okay? So this is something you need to know, that square root of -1 is I. We've been working with our warm-ups with this. Hopefully that's been plenty of practice. However, today I want to introduce a different one. So if I was to write square root of -1 equals to I, look up. Let's say I wanted to get rid of this radical here on the left side. So what cancels a square root? Well, a squared. And whatever I do to one side, I do to the other side, which means this cancels this. So that means I'm left with -1 equals I squared. Copy this down in red. That's another fact that we need to know and we're going to be using. Now, these two are going to be used a lot from this point forward, so make sure you keep those in mind. Square root of 1 is I, and -1 is I squared. Now, how does that look, Mr. Q? Well, remember in the warm-up for the multiplication part, we came up with I squared minus 13I plus 36. You guys remember that? And I said we can do one more step. Is that correct? Yes. So check this out. Now we can do the next step. Notice that we have a what? I squared. So what would I substitute in there? That's true, -1. That means I bring down the -13. And instead of I, what would I substitute in there? Yeah, square root of -1, square root of -1. Bring down positive 36. Now that we're here, now let's look at it. Can I simplify this? Yes, I can combine like terms. I have -1 and positive 36. That gives me 35. Now, if I can multiply the 13 in here, can I simplify this anymore? No, Mr. Q. Okay, so I'm going to leave it as -13i. And this is already simplified. Simplified. See how we're doing now with substitution of imaginary numbers given values for negatives? That's what we're going to be doing. So let me give you another one so we can practice this. Here we go. Example 4, don't copy the instructions. It just says square the following imaginary number and simplify. So copy this one, 5i. So for 5i, they say they want us to square it. So what does that mean? Square it, which means what? 5i times 5i. So let's do numbers times numbers, variables times variables. What is 5 times 5? 25. What is I times I? I squared. Can we substitute at the end? Yeah, what is I squared, guys? Oh, I squared is -1, Mr. Q. So bring down the 25. What is 25 times -1? -25. Does that make sense? Yeah? You're like, yeah, Mr. Q, all we have to do at the end is just substitute that negative. Yeah, pretty much. Let me give you one more. Still have time for one more. Here we go. Example 4Q. We have -I times square root of 2. -I times square root of 2. All right, so what are we doing? We're squaring it and simplifying. So let's square this. What does that mean? -I square root of 2 times -I square root of 2. Once again, variables times variables, numbers times numbers. Here we go. So what is -I times -I? Negative times negative is positive. I times I is I squared. Okay. Next, square root of 2 times square root of 2. We get square root of 2 squared. Okay. So what do we know about I squared? Oh, that's -1, Mr. Q. Okay. And what do we know about squares and square roots? They cancel. So we're left with what? 2. So what is -1 times 2? That's -2. Kind of, sort of, yeah? Yes, Mr. Q. All right. So that's our session for today. Your home plate for tonight, once again, is pages 122 to 123, Michael Jordan. 123 only. Once again, if you're still needing the support, see me after lunch for tutoring. Have a good one, guys. If I don't see you there, be there or be elsewhere. Catch you guys later. Peace. Have a good day. Later, guys.